control room, which is more or less the heart of the tower, will then decide which programmes are going to be sent to where.
And where are they sent? How do you get them to the rest of the country?
Well, dishes like this are used to transmit the signals over to the next repeater stations. So microwaves only travel about 100 kilometres at a time, so if we want to go all the way up to Scotland, say, we've got to bounce the signal bit by bit.
Microwaves, like light, only travel in straight lines, so their maximum range is only about 100 kilometres, because the Earth's curvature gets in the way. To transmit microwaves over long distances across country, repeater stations are used. Microwaves are received by one dish and retransmitted by another until they reach their target.
When it reaches the next transmitter, the signal's converted into radio, so it's doing the next step up through the spectrum, and it's transmitted out to your telly, and you get the picture.
So just you and all these dishes is all it takes to send all those pictures around the country?
Me, all these dishes, and Alistair.
Good grief! What are you doing up there?
Hi, I'm checking the alignment of the dish.
The alignment of the dish, what's that for?
Well, you have to make sure the dishes shoot line of sight, straight towards each other.
Do you suffer from vertigo?
Luckily not, no.
And what about the fact that all these microwaves flying around, you might get fried?
Well, this one's turned off right now. You can't work in front of them if they're turned on.
Alistair, thanks. Katie, we've covered the UK with our television signals, but what about the rest of the world?
To get to the rest of the world, we can't keep on hopping. What we do is send the signal down to Goonhilly.
Goonhilly is in Cornwall. This map shows the route the signal takes as it's relayed between London and Goonhilly.
Goonhilly, we've got huge dishes, and they transmit the signal off into space. We've got satellites up there that receive it, and we direct the beam back wherever we want it.
So you must be a pretty good shot to hit those satellites.
You've got to be a good shot. You're going 15,000 kilometres. But even with the best controls we've got, we're still losing 99% of the signal.
Wait a second, you're losing 99% of the signal? This is very important. If 99% of the signal is lost, that means there's a very good chance that alien life forms out there somewhere are receiving the rest of it. Imagine that. Aliens watching reruns of I Love Lucy. Bill and Ben, the Flower Pot Men. The news read by men in black suits and bow ties.
If aliens are picking up our TV signals travelling through space, they will receive them in tens of hundreds of years from now, because they are light years away. So they will be looking at our history.
Aliens or not, the electromagnetic spectrum is ideal for seeing things that the eye can't see. The human eye sees in the visible part of the spectrum. Special cameras and scanners see in other parts of the spectrum. For years, we've used X-rays to look into the human body, but now the biggest X-ray machine in the world is being used to catch smugglers.
Customs at the border of Hong Kong and China are using one of the world's biggest X-ray machines to help them find illegal contraband smuggled in trucks. Trucks arriving at the border are driven onto a platform which carries the lorry through the X-ray chamber by remote control. Nobody is allowed inside the chamber while the lorry is being X-rayed, because exposure to very high energy X-rays would be very dangerous. X-rays can damage body cells and might lead to cancer. As the truck moves along the chamber, it passes an X-ray machine which is about 50 times more powerful than the type used in hospitals to X-ray broken bones. The X-rays are so energetic that they can penetrate up to 30 centimetres of steel. Low-energy hospital X-rays will penetrate soft tissue more easily than high-density bone. This shows up as shades of black and white on the X-ray picture. Similarly, high-energy X-rays will pass through packaging more easily than very dense materials, like the engine case or steel frame. This difference in density allows the X-ray machine to produce black and white or computer-enhanced colour images. A continuous stream of lorries passes through the X-ray plant night and day on their way into Hong Kong. Not surprisingly, customs have their successes. Not many smugglers yet know that it's possible to X-ray a truck.
Like the human eye, TV cameras detect visible light, The less visible light there is, the harder it is to see what's going on. That's where infrared comes in. Infrared can be found just beyond the red part of the visible spectrum.
Infrared, like X-rays, can be used in surveillance.
I'm at the Metropolitan Police Air Support Unit in Essex, and right now you're looking at me through an infrared camera. It's the latest bit of kit being used by the Met and other police forces to help track down villains in the act. The camera is located in this white ball at the front of the helicopter, and it's especially useful when trying to catch criminals at night, because unlike a normal camera, it doesn't need visible light to see. There's also a conventional camera in there, which, when used in conjunction with a spotlight at the back of the helicopter, takes over when the infrared has located the baddies.
I think the vehicle drove off whilst the PC was arresting him, MP. Stand by.
If you really want to know how this infrared camera works, I've been told the guy to talk to is Greg. How you doing, Greg?
Pleased to meet you.
Tell me all about this infrared.
Well, what we need is something hot to look at first, so if we get hold of Pat here.
In you go, Pat.
What you're looking at here is a thermal image picture made up of heat images. You can see where the skin is.
Yeah.
It's quite hot there, and then as we come down the clothing, the image becomes darker.
This sequence was filmed in complete darkness using an infrared camera. The hot water in the kettle is radiating infrared. The camera is detecting this radiation and creating a black and white image from the information. The hotter the object, the whiter it appears in the picture.
And can you see that in colour as well?
Well, you can see that in colour as well. Right, there you have a rainbow image and an ironbow image. And you can relate this to hot and cold, because if you imagine a hot piece of metal glows white, and when it's cold it's blue, you have a palette on the bottom here going from blue to white with numeric temperature readouts as well.
The camera can only see shades of black and white, but a computer can represent these shades as colours.
And in fact, this comes in rather useful with fire brigade operations.
Yeah.
Where you can actually tell fire officers where a building is starting to heat up, and which we had in Southall some months ago.
You actually filmed that yourself?
Yes, we did.
So it can see hot objects, but what about someone that's running away and trying to hide?
We've set up a little experiment here. You can see this bush.
There's no one there?
There's no one there, is there?
No.
No, you wouldn't think there's anyone there anyway because of the foliage. So if we flick to TI or thermal imaging...
Ah, is that someone standing there?
Yes, that's Pat.
There she is, look.
Cruise the aircraft, cruise the aircraft.
Sounds like we've got a call, Jason. Want to join us?
Absolutely.
The helicopter crew was looking for a suspect who had abandoned a stolen car and had run into the woods. The suspect thought that he was safe amongst the trees because he was out of sight. He wasn't counting on the police having an infrared camera. Another successful mission. And the culprit was caught green-handed?